So, a very big hello to all of you. Today, we are going to be doing a topic which somewhere, all of you have touched slightly, but without actually knowing that you were doing this topic. When you were there in earlier classes, remember when you were having to find out the value of one variable from many, you had to divide. If I give you a very basic example, suppose you were told that two toffees cost 10 rupees. How much would one toffee cost you? Obviously, it will cost you 5 rupees. So what have you done? You have divided 10 by 2, and that's how you got 5. So whenever you had to find out the value of 1, you would be finding dividing it and finding out the value of 1. Similarly, if you were given the value of one variable, suppose you were told that you have to go to a shop, your parents gave you some money, and you were asked to go buy some toffees. You knew the cost of one eclair to be 2 rupees, and you had to find out the cost of 5 eclairs. So you would very simply multiply 2 into 5 and get 10 rupees. So what did we learn? To get to one unit, we had to divide, and from one to many, we had to multiply. So this, when we combine from getting to many to one and from one to many, this particular method is called unitary method. And this is what we're going to be doing about. You may be thinking that why are we doing such an easy thing? You will come to know later that there are some variations in this method also. So let's just go about what unitary method actually is, right? So now I think you can see my screen. The definition of unitary method, as it says, is first we find out the value of one variable given the value of many. Once we found out the value of one variable, then we find out the value of multiple variables. Is that okay? So just let me start with a very simple example. Now, suppose in 4 hours, a man runs 20 kilometers. Now, he's running 20 kilometers in 4 hours. And as the line diagram also suggests to you, I've divided this line into 4 hours: one, 2, 3, and 4. In each one of them, he is running 5 kilometers, 5 kilometers, 5 kilometers, and 5 kilometers. So that's a total of 20 kilometers. So you can see actually, practically also, that the man is actually running 5 kilometers an hour. But mathematically, how do we do it? Now, there are two things when we were taught how to write statements. Whatever has to be found out should be kept in the right. So let me try and write down my statement. Now, what do we have to find out? How many kilometers? So there are two variables in this particular question. One is hours, the other one is variables. So I write my hours on the left and the kilometers on the right. So my statement has to be written in such a way that my hours come on the left and the kilometers come on the right. So my first statement as it is very clear. In 4 hours, a man runs 20 kilometers. In 4 hours, a man runs 20 kilometers. So as we said in unitary method, first now I'm going to try and find out the value of one variable. So let's get back here. So in 1 hour, the man runs, as we said, that for trying to find out for one, we have to divide. So it will be 20 divided by 4. And if you divide, this is going to give you 5 kilometers. Now you found out for one. Now you have to find out from one, you need to find out for many. So we have to find out actually for how many hours? We have to find it out for 3 hours. So from one, we now try and move to 3 hours. In 3 hours, the man runs. And remember what we do for finding out for many? We used to multiply. So the man runs. We found out for 1 hour. So this is 5 into this 3, which is the 3-hour variable. And so we get he runs 15 kilometers. Remember, another very important thing that you've always been told is that you need to write an answer statement. Therefore, in 3 hours, the man runs 15 kilometers. So, what was the method? We first found out for 1 hour, that is unit. So, that is why unitary method. And from that one, then we found out for many, and so that is from unit to many. So, as I was telling you in the beginning itself, unitary method, as the name suggests, first that we need to find out the value of one variable, and then we need to find out the value of many variables. Is that okay? Is so this will be the basic concept of unitary method. But it is not always that we have such a thing that when we are finding out the value of one variable, we need to divide. Now that we've grown bigger, we will understand that there are certain cases where when we find out the value of one variable, you actually do not need to divide, you need to multiply. So let's just scroll down and see this particular example. If two men finish a piece of work in 4 days, like suppose I have two men who are painting a wall and they take 4 days to paint the wall. Now, instead of two men, I double the number of men. I take four men. So, is it actually going to take more time to finish that work, or will it take less time? Obviously, it will take less time. So, my concept of dividing has actually not worked. From two men, if I reduce the number of men, I'm not going to get lesser number of days in which the work is going to be finished. I'm going to get more days. So in division, obviously things become less. Like when I'm saying two toffees cost 10 rupees, one toffee costs less. But in this case, two men took 4 days. So one man is not going to take lesser days, he's going to take more days. So what have I actually done? When one variable, that is the number of men, is increasing, the number of days is increasing, decreasing. And when the number of men is decreasing from two, it's come down to one, the number of days in which the work has to be finished is increasing. So this concept of division will no longer hold now. And this is the classic case of the two variables not varying directly. They are not, if one variable is increased, the other variable is not increasing. Like if the number of toffees is increasing, the cost of all the toffees is also increasing in the first case. But in this case, what is happening? If the number of men is increasing, the number of days is going down. So as the name suggests, when one variable is going up, the other variable is going down. So this is a case of inverse variation. What is it? It is a case of inverse. Inverse, as the name suggests, one is going up, one is going down. So in this case, how do I deal with the sum? When I have, you are going to follow the same concept that you're going to find the value of one variable and then many variables. But when we find out one variable, will not be doing division, we'll be doing something else. Obviously, if it's not division, what are we going to be doing? The inverse of division is multiplication. So let's just do that. So if two men, again, what are the things which are there? The two variables, men and days. The question says in how many days. So days is the variable which I need to find out. So it has to be kept on the right. So I keep my days on the right and I keep my men on the left. So keeping that in mind, I start with my first statement. Two men finish a work in 4 days. Now, this is the most important part which we are now going to do. One man then finishes the work. This time I'm not going to divide. As I told you, I'm going to do the inverse of division, and that is multiplication. So he finishes the work in 4 into 2 days, that is 8 days. And if you think logically also, I've reduced the number of men. When I had two men, it was taking 4 days. So now it's just one man. He has to do the work of both the people. And so it's going to take double the time, and it is 8 days. So what did we do? The major thing, the major change here was that instead of division, we multiplied. Now, when we have to find out for many, now how many men are taken? Actually, we are taking four men. So now let's find out for four men. So four men would finish the work in now For finding out for multiple people, I will have to divide. And so it's going to be 8 divided by 4, which is 2 days. Please keep in mind that whatever is the quantity on the right has to be divided by the quantity on the left. Is that okay? 8 divided by 4. Similarly, in your first example also, when we did this, we had the quantity on the right was divided by the quantity on the left. It's always that. And so it is very essential that you understand what is the variable you need to keep on the right and what is the variable you need to keep on the left. Because if you do it wrong, your answer is going to come wrong. Now, I'll just tell you what could you the mistake that you could have made. Now, if I'm just going to do it in red so that you understand that it is a wrong thing that I'm doing. Suppose I had kept my hours on the right and men on the left. What would have happened? Sorry, I have hours and kilometers. My mistake. One sec, just give me a moment. Kilometers. So I had to find out kilometers, but now I have made a mistake and I've kept my kilometers on the left. So I write 20 kilometers is run in 4 hours. As unitary method says, I need to first find out 1 kilometer. So 1 kilometer then would be run in 4 by 20 hours. And then finally, I need to find out for 3 hours. So like, how am I going to write here? 3 hours is already here. How will I get my kilometers? So that's going to really create a real confusion. I already know my hours. I need to find out my kilometers. So how would I get this kilometers from this? This is not the right way, obviously, of writing the statement. So a request to you, please try and understand that you are supposed to be writing whatever has to be found out on the right. Is that okay? And once you are done doing the sum, it is a must that you write the answer statement. So your answer statement then here is, what is your answer statement? That we have found out that therefore, what was the answer statement always has to be the answer to the question that has been found out. What was the question that was written to you? In how many days will the same work be finished by 4 men? So what will I write as my answer statement? Therefore, the work will be finished by 4 men in, sorry, yes, by 4 men in 2 days. Is that okay? So this is how you do it. So if I was now to introduce the concept of inverse variation and direct variation by way of a definition, let's scroll down to that. Yes. So the concept of direct and inverse variation, if the value of the second variable, now I've been telling you that there are always two variables. In the first case, we had the car doing some kilometers in some hours. So if one variable, the number of hours is increased, the number of the number of kilometers also goes up. And similarly, once. Okay, I have to cut this part of the video. Never mind. Okay. So as I was telling you, I had two variables in the first case. One was hours and the other one was kilometers. So when I increased the number of hours, the number of kilometers also went up. And so because of that, so as I was telling you, in the first case of direct variation, we had two. How do I do not disturb मैंने turn on किया फिर भी fraud आ रहा है. Okay. Okay. So as I was telling you, the first case had two variables. One was the number of hours, and the second was the number of kilometers. So when I increase the number of hours, the number of kilometers also, the journey traveled would be more, and so the number of kilometers also went more. Hours more, kilometers more. First variable increases, second variable also increases. So let's have a look at the definition of direct variation. If the value of the second variable increases when the first variable increased, it is said to be a case of direct variation. Let's have a look at the few examples. If the number of toffees is increased, then the price to be paid is also going to be increased. Second, if you are, say, purchasing some tickets for a train journey and you increase the number of tickets, the amount to be paid is also going to be increased. So that is when we are talking about direct variation. Now let us come to the place when you are talking about indirect variation. When the value of the second variable decreases. Now I had given you an example of number of men and the work done in a number of days. So when I decreased the number of men, the number of days in which the work would be completed actually increased. And when I increased the number of men, the number of days decreased. So when the second variable, when the first variable is increased, the second variable decreases. Is that okay? So there is a case of inverse variation. So let's just see what could be the examples. At 30 kilometers an hour, a scooter takes 2 hours to complete its journey. If the speed of the scooter is increased to 60 kilometers an hour, obviously, do you think it's going to take less time or it's going to take more time? It is going to take less time. And so the time taken will decrease. Similarly, if two workers take 2 days to paint a wall, then if I increase the number of workers, the time taken is going to be less. So this is how we are going to be talking about direct and inverse variation. Now I'm just going to be doing a few questions on the board for you. So you can see this question on the board. A train covers a distance of 51 kilometers in 45 minutes. How long will it take to cover 221 kilometers? First of all, the first thing, whenever we get a question like this, we need to identify whether it is a case of direct variation or it's a case of inverse variation. So let me see, if I increase the number of minutes, if it runs for more minutes, what do you think? The distance covered will be more or will it be less? Obviously, it will be more. So it is a case of direct variation. Okay. Indirect variation. What did we say? For finding out the value of 1, we need to divide, and for many we need to multiply. So we'll keep this in mind. Also, before we start doing the question, we need to identify what are our variables. Our variables in this case are distance, that's kilometers, and time in minutes. What do I need to find out? How long? That means I need to find out the minutes. So I'll keep my minutes on the right and I will keep my distance on the left. Okay. So that having been said, so let's write down the first statement. Remember, I need to keep my kilometers here and I need to keep my minutes here. So a train runs 51 kilometers in 45 minutes. Kilometers in 45 minutes. I've been able to write it like that. So a train runs 51 kilometers in 45 minutes. Now I need to find out, in the next step, I need to find out for 1 kilometer. So the train runs 1 kilometer in 45 upon 51 minutes. Now there's something very important here.
Please do not spend time in cancelling here, because later on you may find that this denominator gets cancelled with the next numerator that you are going to be using. So let this remain as a fraction for the time being, so that you do not waste time first now in dividing and later on in multiplying. Is that okay? Let this remain as it is. Now I need to find out for 221 kilometers. Therefore, the train runs 221 kilometers in 45 upon 51 into 221 minutes. Now, 51, if you are slightly good in your tables, you will know 51 is a product of 17 and 3. So, this is divisible by 3. This 2 plus 2 plus 1, 4 plus 1. Remember your tests of divisibility? This sum of the digits 5 is not divisible by 3. So let's divide these two by 3. Here you'll get a 17 and here you'll get a 15. That being so, I'm quite sure 221 and 17 will cancel. So let's just see. 17 ones are in 22, 17 goes one time, leaving a balance of 5. In 51, again it goes 3 times. So you're left with actually 15 into 13. If you're good in your multiplication, you should be able to get it like that itself. 13 tens are 130, 13 fives are 65. So add 130 and 65, you're going to get 195. And otherwise, you can multiply yourself. You're going to get 15 into 13. 13 fives are, what is 13 fives are? It is 65. Sorry, carry the 6. And you have 13 ones are 13 plus the 6. So you get your 195. 195 minutes. Now, when you get something as 195 minutes, do I go and tell someone that I'm going to take 195 minutes and reaching, or should I convert it into hours and minutes? Actually speaking, you should be converting it into hours and minutes. Now, you know, each one of you, that 60 minutes make an hour. So, if I have to convert 195 into hours, I'll divide by 60. And what do I get? It goes 3 times 180 to leave me a balance of 15. So this is nothing but 3 hours and 15 minutes. And remember what I told you? You have to write down the answer statement. Therefore, the train runs 221 kilometers in 3 hours and 15 minutes. Is that okay? So this is how you're supposed to be attempting your questions. First, identify what kind of a variation is it. We identified it was direct. Then we looked for the variables. We understood that they were kilometers and minutes. And then we used the concept that for direct variation, for finding out one, we divide, and for finding out many, we multiply. Is that okay? I'm going to be doing another sum. So we'll just do that in a second. So this question says that 45 cows can graze a field in 13 days. How many cows will graze the same field in 9 days? So let's, as usual, first try and identify what kind of a variation is it. If I increase the number of cows, obviously the grass is going to get consumed in more days or lesser days? Lesser days. So increasing the cows, the grass goes down. What kind of a variation? It is inverse variation. So, okay. The first thing that we should always write also in our answer that it is an inverse variation. So for 1 we need to multiply and for many we need to divide. Okay. That having been done, now let's try and identify the variables. I have cows on one hand, I have cows, and on the other hand I have days. What do I need to find out? How many cows? So how many cows? My cows has to come on the right and my days has to come on the left. Having said this much, now try and write this first statement in such a way that the days comes in the front and the cows comes behind. So in 13 days, a field is grazed by 45 cows. So in one day, if I just say that so many cows come in that the entire field is grazed in one day, let's see what's going to happen. In one day, the field is grazed by, for 1, we need to multiply. So that's going to be 45 into 13 cows. What did I tell you in the previous question? I'm not going to try and waste my time in doing the product here because later on I may be actually using this for division. So I need to find out in 9 days. In 9 days, the field is grazed by. So if in one day there were that many cows, obviously if the same field it's taking now 9 days for the grass to be finished, the cows would have reduced. When does it reduce? By multiplication or by division? By division. And we've already written that for many we need to divide. So it's going to be 45 into 13. And what was that figure here by which we needed to divide? This was by 9. So I divide by 9. And what do I get? 9 fives are 45 and 5 into 13 gives me 65 cows. So did you understand how easy it becomes had I not multiplied and then divided? But on the other hand, if I had found out the product, it would have become a larger number and so more difficult to divide. Here this was very, very easy. So now my answer statement so then becomes how many cows will graze the same field? So I'll write 65 cows will graze the field in 9 days. So this was a question of inverse variation. How did we identify that? We identified it by looking at one variable, that is the number of cows going down when the number of days came up. Is that okay? So we'll move on to the next question. So the question up here is, now a camp has food for 120 men for 200 days. After 5 days, something happens because of which 30 of them die. How long will the food now last? Instead of 120 men, now you have lesser number of men because 30 men have died. First of all, let us see, as usual, the kind of variation it is. Okay, I by mistake have left it from the previous board itself. Yes. Now, if I increase the number of men, the food will last for more days or will it last for less days? It will obviously last for less days. So it is an inverse variation. And as we've learned, for inverse, when I have to find out for one, I multiply, and when I have to find out for many, I divide. But there is a slight change in the kind of question. Now, just understand that initially there were 120 men, and at that time it would have lasted for 200 days. Now, after 200 days are over, how many days are, sorry, after 5 days are over, how many days are left? 195 days. Had those people still continued, the food would have lasted for 195 days. Agree? So, let's just change this part a little. After 5 days, with the same situation, the food would have lasted for 120 men for 195 days. Because how many men have gone? How many days have passed? 5 days have passed. But at that time, what happens? Sadly, out of those 120 men, 30 men died. So, at that time, what happened? How many men are left? So, only 120 minus 30, that is 90 men are left at that time. So, going according to the question, the food would have lasted for 120 men for 195 days. Now, I need to find out for 90 of those men, how long would the food last, right? So, we have to not pick up that particular statement. We have to pick up the statement that 120 men, the food would have lasted for 195 days, okay? So, let's just identify our variables. What needs to be found out? How long? That means for how many days. So, I need to keep my days on the right and my men on the left. So, the statement which I need to pick up now is this one, not the previous one, because from that we have been able to arrive that had we got the same number of men, it would have lasted for 195 days. So, for food would last for 120 men for 195 days. Instead of 120, if I just took one man, obviously it would have lasted for many, many days. So, food would last for one man for inverse variation. What do I need to do? For one, I need to multiply. So, that is 195 into 120 days. That having been said, do I multiply? No, I'm not going to waste my time and my resources in multiplying. Now, I am then going to find out for 90 people who are still left, how long would the food last? Food would last 90 men for 195 into 120 upon 90. If you see the 0 and the 0 cancel, both these things are divisible by 3. So, I get a 3, I get a 4. 1 plus 9, 10 plus 5, 15. The sum of the digits is divisible by 3. So, this is also going to be divisible by 3. When I divide 19 by 3, I get 6 with a balance of 1. In 15, 3 goes 5 times. So, it's 65 into 4, which is nothing but 260 days. Is that okay? So, here goes my answer statement that the food will now last for, because my question was how long will the food last now? So, the food will now last for 260 days. So, is that okay? You can address slight differences in questions, but using the same methodology. Whenever you are given a sum, first try and identify what kind of variation it is, whether it's inverse or direct. That will give you whether you need to multiply or divide first. For inverse, for 1 we multiply, and for direct, for 1 we divide. After that, identify your variables. Keep the variable which has to be found always on the right, and go on to write your statements for many, for one, and then for many. Also do write your answer statement. Is that okay? The rest we can do in a physical class. Your numbers for my classes are mentioned. Please get in touch with me if you need. Thank you.